It was a blessed second when the Andromeda cloud, for the time being, turned into the Andromeda world. For quite a long time, how we might interpret the Andromeda system was restricted to ground-based perceptions. However, with advancements in innovation and the introduction of the James Webb Space Telescope, our comprehension has developed beyond measure. Now, things are going to change as the James Webb Space Telescope has identified disturbing signs coming from the Andromeda universe. These signs have sent shockwaves through established researchers, leaving cosmologists both roused and inquisitive. Yet, what precisely do these signs mean? In particular, why are they causing such a mix among cosmologists? Join us as just 2 minutes prior, the James Webb Telescope shut down after receiving disturbing signs from the Andromeda universe. Before we could see a long way beyond our eyes into the universe, cosmologists trusted the smooth method for being the entirety of the universe. This lack of knowledge was fundamental due to restricted innovation for seeing different worlds and personal stars. However, everything changed when we found the Andromeda system. It served as our most memorable clue that the universe extends far beyond the smooth way in human imagination. Everything began in the 17th century when Galileo Galilei's pioneering work with telescopes uncovered the smooth way's real essence. He saw that the smooth way had various stars, challenging the overarching thought of its solitary significance. Everything changed during the 1920s when Edwin Hubble discovered far-off objects beyond the smooth way. Using the Hubble Space Telescope, Edwin saw that these heavenly objects traveling through the universe were galaxies, not the same as the smooth way. One of the galaxies was the Andromeda Galaxy, or M31. While this was the first time we were seeing the Andromeda universe through a telescope, Persian stargazer Abd al-Rahman al-Sufi initially noted it around the 10th century. Researchers believe that to have a superior comprehension of our universe and the smooth way, we should study the connection between Andromeda and the smooth way. This is particularly true given that the two galaxies are likely to collide in around 4 billion years. While studies and examinations have advanced, the James Webb Telescope recently received a disturbing signal from Andromeda. This disturbing signal confuses researchers worldwide, prompting questions about its precise origin and potential implications. The James Webb Telescope's high-level sensors have detected strange movement just inside and around Andromeda's center. The signs sent back to researchers show results that contrast significantly from past observations, fascinating researchers globally. The signal reveals major processes occurring inside the galaxy, potentially linked to its massive black hole or previously unseen events. Evidently, one of the most recent discoveries indicates that Andromeda's mass might be much greater than that of the Milky Way, reshaping our understanding of the two galaxy sizes. The James Webb Telescope has provided detailed images and spectra of Andromeda, unveiling the arrangement of new stars and their chemical compositions. This new information is crucial for understanding cosmic evolution and potential conditions for life. Additionally, the data from the telescope suggests increased activity in Andromeda's dynamic cosmic core. This has ultimately influenced its surrounding environment and is anticipated to shape its future structure. Furthermore, by investigating the gravitational effects on stars within Andromeda, specialists gain insights into the distribution of mysterious dark matter throughout the galaxy. Hopefully, this advances our understanding of its impact on the dynamics at play in the universe, as understanding dark matter and its influence on the universe remains one of space science's greatest mysteries. Recent breakthroughs by the James Webb Telescope have spurred further investigations around the world. As researchers explore the mysteries of Andromeda, with more coming to light, we now know more about the universe's past and future. So, what have we discovered about the Andromeda Galaxy through various investigations? Andromeda has shown remarkable qualities that distinguish it from other galaxies across the universe. Its sheer size commands attention, with recent estimates suggesting a diameter of around 220,000 light-years. This makes it one of the largest galaxies in the nearby group, even larger than the Milky Way, comprising an estimated trillion stars, surpassing our galaxy in stellar count. Specialists also find the galaxy's structure fascinating. Unlike a typical spiral galaxy, Andromeda has a bulging center and a dense core surrounded by rings of dust and gas. This is undoubtedly a prolific ground for ongoing star formation. Such features indicate a dynamic galaxy shaped by persistent processes. Among its many characteristics, one of particular interest is its core, marked by a double peak emission, indicating the presence of a very large black hole, albeit different from the Milky Way's. The Andromeda Galaxy is also surrounded by a halo of stars, planetary and globular clusters extending hundreds of thousands of light-years in diameter. This vast envelope tells a captivating story of the galaxy's unique formation and history. The 460 globular clusters found in Andromeda also offer insights into the formation of stars in the galaxy's early stages, providing a clearer understanding of the arrangement of star clusters and the galaxy's early evolution. By unraveling the mysteries of Andromeda, cosmologists are one step closer to grasping the grand significance of dark matter. However, one question remains: how do they account for its enigmatic nature and the role it plays in the dynamics of galaxies? Andromeda boasts another distinct feature: its satellite galaxies. Its core structure comprises more than 20 smaller galaxies, some of which are being stripped of their stars and gas by the larger galaxy. This process involves a larger galaxy pulling in and destroying neighboring smaller galaxies, demonstrating the dynamic nature of astronomical evolution and illustrating how galaxies grow and interact over time. So, what does the future hold for the Andromeda Galaxy? The shape and trajectory of its evolution captivate astronomers as well as those seeking to understand the universe. The potential for its transition from a spiral to an elliptical galaxy is particularly crucial in Andromeda's development. Evidence points to an interaction that could lead to other intriguing mergers, perhaps from cosmic collisions or close encounters with other galaxies. If Andromeda truly is moving in this direction, it suggests that it has undergone numerous interactions with other galaxies since its formation. Ultimately, Andromeda's future hinges on the inevitable collision with the Milky Way. According to models, this collision is expected to occur in about 4 billion years. The result of such an impact would be the formation of a new galaxy from these two massive cosmic entities. Although the collision would be catastrophic, it is a natural part of cosmic evolution. However, due to the vast distances between the galaxies, this cosmic collision is not an immediate event. After the impact, the two galaxies would be fundamentally reshaped, creating new structures and compositions. The merging of their gases and dust would stir up a new cycle of star formation, leading to a spectacular display overhead as the merging objects shine brightly. This astronomical event would result in the creation of a single elliptical galaxy. Such impacts are not unique, as the universe has a long history of such events, but our direct involvement makes it a significant event for us. Additionally, the anticipated collision of the supermassive black holes at the centers of the two galaxies adds further intrigue to this cosmic spectacle. This suggests a complex and profound nature of massive evolution. The merger is expected to produce explosions from matter being consumed by the black holes, resulting in intense radiation. This process provides valuable information about how galaxies evolve throughout their lifespans and how black holes influence this evolution. However, it raises a crucial question. What will happen to our solar system after this merger is completed? Far from an outright destruction of the local planetary system, the nearby planetary system's trajectory and conditions could be altered significantly. This suggests possible orbital shifts or even ejections from the newly formed galaxy. To understand this mechanism, researchers can study the scale of similar events and contextualize the inevitable fate of our own solar system. It is important to understand that collisions between stars are rare in space due to the immense intergalactic distances. However, gravitational changes could disrupt stars' stable orbits, causing some stars, including our Sun, to shift direction. Such a change could significantly impact Earth's climate, potentially leading to either warming or cooling effects. A warmer climate could cause ice caps to melt and sea levels to rise, while a cooler one might trigger a new ice age. Additionally, such a shift could obstruct radiation levels reaching Earth, creating even more challenging conditions. The merging of the Andromeda and Milky Way systems highlights the intricate relationship between celestial bodies. As the black holes in the two galaxies come closer over time, their gravitational interactions may increase the aggression of high-energy particles that could reach Earth. This potential increase in radiation levels could pose a threat to Earth's ecosystems, potentially leading to increased mutation rates in populations and affecting biodiversity. The eventual alignment of Earth's orbit or axis resulting from the black hole merger could impact how ecosystems are distributed. How living beings will adapt to environmental zones that may become inhospitable is one of the impacts of climate change experienced globally through shifts in biodiversity and ecosystem structures. Although some species might thrive under the new conditions, others could become extinct or face severe threats. The contrast between Andromeda and our galaxy can be used to develop more accurate models for cosmic dynamics and evolution. The reassessment of Andromeda's size and mass is a significant effort as it directly informs our understanding of the Milky Way and its structure. As a result, it has challenged our initial assumptions about Andromeda and the need to reconsider its importance in our cosmic neighborhood. Recent data suggests that both the Milky Way and Andromeda galaxies are comparable in size rather than our galaxy being much larger. This contradicts our understanding of the Milky Way's role within the local group of galaxies and its gravitational influence. While the Milky Way currently appears as a spiral galaxy, its structure could change due to its interaction with the Andromeda Galaxy and the forthcoming collision. Ongoing studies have revealed intriguing differences in stellar populations and compositions between the two galaxies, with Andromeda appearing younger and more active in its star-forming regions. This implies that Andromeda's evolution is following a distinct path, influenced by various factors. By studying these differences, astronomers hope to uncover key principles governing galactic formation and behavior. Such findings are integral to understanding how galaxies evolve and interact. The findings from the James Webb Telescope about Andromeda have challenged and broadened our understanding of our galactic neighbors and their roles in the universe's complex web. Despite the inevitable collision between the Milky Way and Andromeda, this discovery marks a new chapter in space science and leaves us with many unanswered questions. We may have made progress, but the universe is still full of mysteries waiting to be uncovered, and the James Webb Telescope is opening doors to new possibilities.